Right, I think it's high time to begin the first session in the afternoon. So welcome to the session on the role of philosophy, ethics and society in brain research. I'm very happy to moderate this session, and so maybe I should just say a few words of who I am. Kathinka, I'm a professor of philosophy at the University of Uppsala, Sweden, and I have been leading the research on philosophy and neuroethics in the HBP, and also the Ethics and Society sub-project, and in the early days together with Jean-Pierre Changeux. As Catherine Amonds pointed out in her introduction to the summit yesterday, the HBP is unique compared to other brain initiatives in having included from the very beginning, indeed from the planning stages, humanities and social sciences, philosophy and ethics, into its research core. And this has been a highly fruitful collaboration across the disciplinary divides, and it has also, in some measure, we are pleased to see, helped inspire similar initiatives in other brain projects and also beyond the realm of brain research, notably the OECD. We have today a very distinguished speaker that we are delighted to have with us, Professor David Winickoff, who is a senior analyst at the OECD, where he heads the horizontal program on technology governance and also the working party on bio, nano, and converging technologies. And in this capacity, he oversaw the development and adoption of the OECD Council recommendations on neurotechnology. He's also an affiliated professor at Sciences Po Law School, where he teaches on global governance of emerging technologies. After his presentation, we are going to have some time, I hope, for questions and discussions. But before your presentation, we have a short video that has been produced by the Danish Board of Technology in the aim of providing a very brief and selective overview of the work that the Ethics and Society Group has done for the last years. And for those of you who are interested, there is further material to be found at the Ethics and Society booth outside here. So. By that, I think maybe we could start the video, if I am here we go.
What is it that makes us human? Our brain is more complex than the other animals. It has made us able to use tools, control fire, build supercomputers, and explore the universe. Digital tools allow us to learn more about the brain. What we learn is embedded in and dependent on growing wells of data and tools of automation. Therefore, we find ourselves facing complex, philosophical, social, and ethical questions, and questions about how this knowledge should influence our societies, healthcare, and everyday lives. Over the last 10 years, we have developed a new methodological approach to philosophical and neuroethical reflection that promotes integration of scientific, conceptual, social, and ethical perspectives to analyze the nature of consciousness and criteria for assessing its presence in humans, non-human animals, and machines, social and cultural influences on the developing brain's architecture, the use of digital twins to understand and help treat human brain pathologies, and the ethical and philosophical issues that arise through AI research and its applications. We asked over 3,400 citizens across 19 European countries about how they think brain science should embrace data protection, data and neuroethics, AI and dual use issues. We found that citizens want information that's easy to find and understand. They want to know about the outcomes of research, protection, safety and accountability, oversight and proactive prevention of misuse, They're concerned about commercial exploitation of public research, and they want to be heard on directions and priorities of research. We have developed a data governance framework for the Human Brain Project and the eBrains infrastructure built on people, processes, and technology, including a data policy manual, a management process for ethics compliance, governance policies for the EU research infrastructure eBrains, where we've implemented robust access control model, terms of use, a data provision protocol, and data use agreement, ensuring ethically responsible, socially acceptable, and legally compliant data processing pipelines and workflows. We developed a novel approach to dual use of concern in brain research that considers a range of concerning uses, covering political, security, intelligence, and military domains. The approach has been developed in collaboration between scientists and experts inside and outside the Human Brain Project. This broader approach to dual use of concern has been crucial in raising awareness about responsible brain research because it includes proactive reflection and action. We take equality, diversity, and inclusion seriously and have collaborated across different levels of the Human Brain Project. We've involved everyone from leaders to students. We've created tools and guidelines that enable critical reflection and practical implementation of equality, diversity, and inclusion across the project. Our work has also highlighted the importance of considering gender and other variables to improve our understanding of the brain. Working proactively to counteract biases in brain-inspired AI models and brain research. We created spaces for dialogue between Human Brain Project researchers, experts, and stakeholders. These dialogues have helped us look at the future implications of brain technologies through the lens of the knowledge developed in the Human Brain Project. This work has contributed to shaping policies on data governance, public engagement, and neuroscience, but also as roadmaps for co-creating research in eBrains and build communities of users of the services offered by eBrains and the Human Brain Project. Our parting gift is an intellectual legacy spanning 10 years of publications and insights, a vision for ethics and society in brain research that is embracing human rights, the inclusion of citizens, vulnerable and marginalized groups, and that integrates diversity and gender as research topics. A full and free online training resource to build capacity for addressing ethical and social issues for societal benefit, tested by more than 300 people in the Human Brain Project. And we provide a hands-on toolkit for proactive reflection on social and ethical issues in brain research.
Right, well, special thanks to the Danish Board of Technology for having produced this introduction. And now it's my very great pleasure to ask Professor Winickoff to come on stage. A very warm welcome.
Thank you, Kathinka, and also thank you to Powell and others at the Human Brain Project Summit for the invitation. It's a real pleasure, and speaking of the legacy of the Ethics and Society Project, I think I'll be speaking about, to some extent, where some of that legacy has resided, which is at the OECD, and the recommendation on responsible innovation in neurotechnology. Okay. No.
Excuse me,
Mouse. Left click. Okay. So at the OECD, in the Science, Technology, and Innovation Directorate, there's a major initiative around technology governance, which is built on philosophy, ethics, and other disciplines in the social sciences and humanities. but tries to yield from those insights lessons for how we manage and govern technology itself. But why do we govern technology? What are the rationales for RRI? Well, a few of them we might just rehearse quickly. To anticipate and mitigate social and political disruptions, to promote human values like safety, security, and democracy, to bridge technological divides and address rising inequalities, to promote public trust and trustworthiness deficits in science and technology, and perhaps the inadequate alignment of technology and societal goals. I think it's important to have a list such as this, which is not complete, just to understand why exactly an investment in the humanities, social sciences, into the scientific enterprise itself is so important. The OECD recommendation on responsible innovation in neurotechnology has 9 principles. It was developed and was adopted in 2019. And you can see from the title that responsible innovation was explicitly taken up at the international level in this recommendation, which is the first international initiative or adopted piece of soft law on neurotechnology governance. It wasn't RRI in particular or specifically, but I would say in the orientation of responsible innovation, of being upstream, forward-looking, inclusive, these kinds of adjectives characterize the 9 principles, which I won't read out. But I want to maybe pick out a few: the promotion of the inclusivity of neurotechnology, the fostering of scientific collaboration in neurotech across countries, so international, across sectors, so public and private, and across disciplines, the transdisciplinarity that the Ethics in Society program is built on. The recommendation talks about deliberation, not just engagement, the idea of creating space, a public space for debate and discussion about critical issues of neurotech governance. There's a discussion of a culture of stewardship and trust across the public and private sector. And I think because of the seat of the recommendation in an organization like the OECD, for which economic concerns are important, the engagement of the private sector has been a major theme, and I'll talk about that a little bit more. Of course, within this project, we see some norms that are, I think, quite impressive, that are built upon the 10-year course of work in the Human Brain Project. And it's interesting because there's a congruity with, I think, the OECD recommendations. And it's not an accident. I think they come from similar positions and orientations. And I think it's an important question how an international recommendation or set of soft laws interacts with things like a ethics and society vision or other kinds of entities or codes. And I think the idea of an ecosystem is one that I come back to, that there should be co-articulation and there should be harmonization, but also promotion of diverse ways of touching or approaching the topic. In the OECD, there are 38 member countries that adopted the recommendation. One thing that's particular about OECD recommendations is they need to be, they're monitored. That's to say, countries actually have to provide information back to the OECD about how they've implemented the recommendation. So this is codes of practice, but there's an accountability mechanism. But it also makes clear that we have to think about how recommendations can be implemented. I think this is also a theme, I think, from the talk and some of our work, is it's not enough to just have a piece of paper that has norms or or codes and guidelines. The question is it being used, and how is it being used? And that's a difficult question, and I'll come back to that. But that's critical for thinking about the efficacy and utility of a code of practice. It was a long road to develop this recommendation, and I highlight some activities in 2017 because the program, the idea was to say, okay, in Europe, in the United States, in Japan, there are these major national neurotechnology and brain science projects. Each of them has some kind of ethical, legal, social aspect and program, but maybe those elements are not speaking to each other, and that there's a road or a realm, a space for the collaboration or conversation of these different programs that the OECD could potentially foster and nurture. So this was the idea over time. The OECD convened a big meeting in Shanghai. We welcomed Brain Project actors at the meeting, and it was devoted to looking at Asia and Europe and the United States, or in the Americas, I should say. And this moved and gradually, in a stepwise process, became a recommendation. But after that is the process of implementation, and there have been a number of activities in that regard. And again, a kind of stepwise process. I want to drill down into a couple of recommendations because they have particular relevance to this session and to the Ethics and Society program. One of the key provisions talks about the promotion of interdisciplinary research and development, where communities of science, scientists, and engineers interact closely with the social sciences and humanity communities, as well as with user and other relevant groups. So this was something the countries and delegates came together and felt strongly about, again, drawing on the experiences of brain research programs in their own countries. And this really was an emphasis of those discussions. Those discussions also talked about pre-competitive consortia of collaborative research across public research institutions, private nonprofit organizations, and private sector entities, the co-development of standards, and the international culture of open science. And these are meant to come together in a notion of scientific collaboration in neurotechnology. Recommendation 8 talks about the private sector, the public and private sector. And the idea here, again, is that it's not enough to just think about public sector research, that so much research and development is occurring in companies, that to extend norms around brain science and neurotech that just reach researchers in the public sector would miss a lot, that there are significant gaps. So how do we begin to engage the private sector in developing oversight and governance? The other piece, again, as I mentioned, is the difficulty of implementing norms. And here's, I think, for the eBrain's mission and vision, I think that this is going to be important to think about how different actors, whether they're any of the actors on the right-hand part of the screen, ministries, public funders, regulators, executive organs, researchers, investors, what are the actions, the tangible actions that those actors can do to implement or to push forward the recommendations? And this can be done through mapping, locating gaps, and identifying levers through incentives. So that's a quick sort of run through the development of the recommendation, of some challenges for implementing it, some sense of how it forms part of a legacy of programs like this. Now I want to share a project that extrapolates, that builds upon the recommendation on neurotechnology to try to derive a general tech governance framework that we hope will be useful for everything from AI to neurotech to gene editing to certain nanotechnologies. Is there utility in doing a kind of set of principles that would apply and bring ideas to bear? Developing a common framework is not a one-size-fits-all. Technologies are different, but there are common challenges across emerging tech, the rapid pace of development, the uncertain risks and benefits and trajectories. You can recognize this from the neurotech area. There are multiple applications, industries, and contexts, potentially regulatory agencies. The concerns extend beyond traditional health, safety, and environmental risk to things like the human future, personhood, and that sort of thing. So any response has to take into account specifics of technologies, the level of readiness, the profile of perceived risks, the profile of local, national, and international matters of concern. But the idea is that maybe we can learn across technologies to say something important and general that can be applied across. And so we don't just start from scratch each time a new technology develops. One of the problems at the heart of dealing with technology from a governance perspective is, on the one hand, not wanting to regulate or put constraints too early around technologies, because that could constrain technology, the full consequences of those constraints may not be recognized at the time. We want to promote innovation, and we see how very early governance could potentially restrain innovation. But if we govern later, too late, changing course might be difficult. End-of-pipe solutions are not necessarily socially optimal. And so there's a dilemma of how you negotiate between these two issues of being premature or being too late. And this is behind the framework that we're developing, a desire to be anticipatory in developments of the technology as a way to address this calling ridge dilemma. And we noticed that actors at the country and international levels seek guidance and agreement on embedding values in technology. I was just discussing this with Kathinka. At the OECD, the issue of technology governance is raising in importance. So we're seeing it at the highest political levels. And I think this is a confluence of factors. This is geopolitical concerns that emerging tech is increasingly a terrain on which geopolitics is turning for competition, economic competition, but also defense planning. And for these reasons, there's interest in trying to define a kind of normative approach based on liberal democratic values to try to root technological development in something where there's a vacuum in certain cases. So countries are talking about it, but they don't necessarily know what to do. And so the input here, or the desire here, is to create tools in an anticipatory framework so that countries can think creatively and particularly and have useful resources to govern technologies both nationally and across countries. So emerging tech governance, as we're developing it, has three elements. Has at the kind of bedrock level values, at the next level sort of design criteria of anticipation. We talk about inclusion and alignment. We talk about adaptivity. And then each of those design criteria have tools. And so we're really focusing on how countries and actors can put norms into practice. One of the most important tools, and becoming more important, is forward-looking technology assessment. So how do we actually anticipate? How do we get ahead of the curve, both for understanding the developments of technology, but also for governing and not being too late in that Coleridge dilemma? And we did a study on technology governance or technology assessment across 10 case studies. And we noticed that although tech assessment has been around for a while as a strategy, there are increasingly there are a number of trends that are transforming the practice of tech assessment. There's the turn to missions in the European Union and elsewhere, which push for a problem-centric approach to technology. There are crises that require strategic intelligence on tech options. There's a rapid scaling of technologies. There's values being seen as important for driving technology development. There's the push towards greater inclusivity. There's the demand for anticipatory intelligence for governance. And there's the globalization of technology emergence and governance. So all of these are pushing technology assessment in new ways, and we need to search for adequate and better ways of doing this, and not just traditionally defined in terms of tech assessment, but foresight, horizon scanning, a package of tools that will do this, and we develop some principles for that. Societal engagement is not a new topic for this group, but we break this into three parts: building a deliberative capacity of society through things like education programs, information online, inclusive community building, media and communication training, the communication and consultation of publics and stakeholders through focus groups, citizen juries, citizen assemblies, citizen consensus conferences, and then something that's more like co-constructing technology development through participatory agenda setting, citizen science, participatory tech assessment, and co-creation spaces. We also emphasize soft law as a mechanism for governance, as a way to thread that needle between too soon and too late, or too soft and too hard. So this is a way to be adaptive, and there are many examples of interesting approaches that are occurring in the private and public sector around partnerships, responsible guidelines, risk mitigation checklists, industry best practices, public engagement, etc. So these can be cataloged and used for developing these soft law approaches. And one of the troubles with soft law is that there's not necessarily a legal stick behind it. So one of the challenges is that it's not complied with. But there are a menu of practices around audits and liability that could be invoked in this context. A fourth tool is around mobilizing the private sector for responsible innovation in neurotechnology. And this could be done through a set of tools like enabling responsibility review, responsibility principles as part of a startup's mission, embracing collectively legitimated ethics by design approaches, mobilizing tech transfer as a critical juncture for social impact. I mean, think about tech transfer. This is where universities license out new inventions to the private sector. There are certain public purposes of publicly funded entities like universities. Could that be a place through licensing to have a discussion about potential uses and values of the subsequent inventions downstream? One thing that, I think this is an important point on the private sector, that there isn't a private sector. There's early stage entrepreneurs, there are venture capitalists, there are executives at larger companies, there are big tech companies, there are philanthropic organizations. All these actors have different sets of incentives. Entrepreneurs, they have difficulty incorporating ethical consideration into their workflow because they're just trying to survive. They're moving very fast. Venture wants to align with positive outcomes for society, but often is unaware of how to structure that alignment. Executives at larger companies are more equipped to engage with ethical issues, so often you see the ethical engagement at bigger companies. Big companies often welcome regulation as a barrier to entry of future competitors. And philanthropic organizations tend to lack a playbook to incentivize the implementation of tech ethics guidelines. I'll skip over evaluation in the interest of time, but that's another tool. And I'll also skip over, because it's self-evident in an OECD talk, that international collaboration is critical. And I just wanted to end on a couple of slides to suggest that, you know, in reading through the materials of the Ethics Society outputs, I think there's a lot of potential synergy with OECD implementation efforts, and really would recommend all of these publications and activities. And I think we will be engaging with them moving forward. And finally, are there ways forward with this community? A couple of ideas here. Can we integrate insights and intelligence? Can we do tech assessment across our communities? Build an international forum for the integration of different forward-looking insights around policy challenges? Is there a way to collectivize that intelligence? And finally, can we build a network of key government officials responsible for neurotechnology governance to help countries and communities harmonize their approaches via the OECD recommendations and other shared visions? With that, I thank you, and please get in touch.